Fire escape engineer's inspector summary video. Here we are in Bridgeport, fire escape number 4 of 4 fire escapes on building number 205. What we have here is a lot of debris. So a lot of debris on the fire escape, which is going to be part of the obstruction rule. Can't obstruct. Number 2, we have a fire escape here that must meet the code, must be load tested, and or other satisfactory evidence given to the official to avoid the load test. This fire escape is not ready for a load test. Has nothing but original hardware everywhere. Everywhere is original hardware. Some repairs were all done with welds. You know, instead of changing out the bolt and cleaning out the connection, they just came in, but they left the rust inside. So it's every connection is compromised. We got a lot of cracked sills, and these cracked sills will feed water right into the steel, and that steel will feed all the steel down below because water gets inside here between the veneer and the masonry block wall behind it, and it feeds. So every one of these is not as bad as the other ones. Out of the 4 fire escapes on this building, 3 of them have life safety issues. This one has some issues, but nothing right now that stands out as life safety issue. Every one of these treads has rust in the connection, and it's a quarter plus. Every one of these that has lost their bolts, instead of changing the rust, they came in and welded them, so you got quite a few. All original hardware. But here's a typical situation. You got the water that got inside. Through ice jacking and rust jacking, it broke all your bricks. You can see right in there. Okay? So it's spalling, but it's not as bad as all the other ones. But every single one of these connections on this building has been affected, and at this present time, none of this fire escape can be load tested, or there isn't any satisfactory evidence of strength for us to pass the fire escape under a confidence test. So rust in every connection, original rivets. This fire escape is 50 to 75 years old or older. Now here's a major blowout. Now this needs to be a masonry wall repair. But in the meantime, about 5 inches away, we can put an epoxy bolt in here, 3/4, 8 to 12 inches deep, through the veneer and into the masonry block wall behind. Then with an angle clip that comes back here and picks up with 2 bolts. So it's a big L bracket here. Picking up the new epoxy bolt, we can seal this up, seal all of them, but I wouldn't trust any of these that are going into the building because they've been open for so long. The chances are that the water's getting in from the wall up above, from the roof up above, feeding water down the veneer. These veneers are cracking, and the sills are feeding the steel. And what's going to happen is this is happening. This is all just pulling away from the wall. You see that big long hair crack? See all this crack? See all this right here? That's an indication that water's coming in from the roof and popping these. So we need to reattach somewhere else and no longer rely on what material is left on the steel. And if this is any evidence of the rest of this building, all the other 3 fire escapes, there is no more steel going into the building. It rotted right here. So that's an indication that water is coming from the inside of this building, not the outside. So we may have a roof issue that is going to be feeding water to this fire escape, and that needs to be resolved to avoid having the new attachments all done. So lots of welds. All welds must be either x-rayed or load tested for verification. Otherwise, as soon as you pop some bolts in them, you don't need to verify the welds anymore. All major structural connections need to be redone. All the supports, if they're not rotting into the building, and I think it's this one over here is a perfect example. See, that's how it all starts. The water's getting in there, the water's behind there is rust jacking that out and popping that out. Okay, so the ladder system, all original hardware. There is a life safety issue actually here. The ladder is off track. So something happened on this fire escape so that the ladder, should you release it, first of all, that wire would stop it from dropping. But number 2, once it would go down, it would actually pull away and fall off. So this fire escape is not on track. 2 out of the 3 tracks are off on that side, and 2 out of the 3 tracks are out on this side. So you have to. This does have a life safety. So 4 out of the 4 buildings on this fire on the 205 do have life safety issues. They need major repairs, 100% refurbishment, because there's very little that you can spot repair here and then still not have to load test. All the original rivets, all these need to be swapped out, or a gusset needs to be made so you can keep the original. but every one of these rivets is popping. They're rotted at the back end. You do have lead on this fire escape, so the fire escape, to not contaminate the building and to meet the EPA requirements, everybody that touches this must be an EPA renovator, must have a renovator's license, so that when you scrape this fire escape prior to painting, you're not contaminating any of the building. And we do have quite a bit of scraping. You don't want to contaminate the ground. And again, when this tries to come down, it's going to run right into here. It won't come down anymore, and it's off track anyway here, and it's off track there. So this fire escape ladder, when you release it, it's actually going to fall to the ground. So there's a life safety issue. You're going to trap some people up here. Any questions? Fire escape engineers, inspector summary video. This is Inspector Meneses. 800-649-3333.
you.